Okay, part B of the same question, number 2, October, November 2012, paper 4, variant 3. Okay, now here we are asked, in this question, we're given some diagrams here. You're given a triangle which is shaded, triangle X, and you've got W, Y, and Z. Now they're asking us to describe some of these transformations. So for example, describe fully the single transformation, just one transformation that maps X onto Z. Now if you look at X and Z, okay, it's pretty obvious that it's like reflection. Okay, it's reflection. Okay, you can see that every point here has been reflected kind of vertically downwards. Now, if you want to describe a reflection, you've got to mention two pieces of information. You've got to mention that it's a reflection, because that's pretty obvious, so we can write down reflection. That's one thing. So that's one mark. Okay, if you just write reflection, you just get one mark. Of course, you have to describe the reflection. How are reflections described? Well, reflections are described by the position of the mirror line, or the equation of the mirror line. Now, to find the mirror line, you take a point and you take its reflected image and you see the distance between them and you cut them in half. Okay, the line that passes through, halfway through the image and the object is going to be the mirror line. It's a perpendicular bisector of a point and its image will be the mirror line. So you can see very obviously it's going to be this horizontal line that passes through one on the y-axis. Okay, so this is the mirror line here. I'm just going to draw it that far. That's the mirror line, okay? And the equation of that mirror line, if you draw that line all the way across, it's going to become y equals 1. So we can see that it's reflection, and you can say in the line y equals 1. That's 2 marks. You describe the transformation in fully, okay? Describe fully. Fully for reflection means you give the equation of the mirror line if it's on a grid. Then it says triangle X onto triangle Y. Now X onto Y, it looks like it's some sort of a rotation. It's not a reflection. If it was a reflection, then you see this smaller angle would be on this side here. Okay? So it's not a reflection, it's a rotation. And you can see it's a rotation of 180 degrees. It's quite obvious that it's a rotation of 180 degrees. Okay? If it wasn't 180 degrees, I would say, we need some tracing paper to help us pinpoint the center of rotation. But 180 degrees rotations are pretty simple in terms of locating the center of rotation. Okay, they're kind of very much similar to enlargements of factor -1. Okay, so if I just take a straight line, make it a bit thin, and I join together an image on X. Okay, so X to Y. So I'll take the point, for example, let me take the right angle. It's pretty obvious. The right angle to the right angle. Join them together. And then I take a point, let's say the bigger angle out of the other two to the bigger angle of the other two. So it's going to be from this point here to that point there. If I join those together, where they meet, you've got to try and be accurate, where they meet, that is the center of enlargement. Sorry, well, you can think of it as that, the center of enlargement, or you can think of that is the center of rotation. So this has been rotated 180 degrees, okay, 180 degrees, okay, all the way about the center of rotation. You don't have to say clockwise or anti-clockwise, because it's 180 degrees, whether you go clockwise or anti-clockwise, it will give you the same answer. So I can write here that this is a rotation, 180 degrees, and you can say the center of rotation is this point here, which is 3, 2. You can say it's 3 and 2. That's the center of rotation, 3, 2. Alternatively, if you wanted to, you could even call it an enlargement. You can call it an enlargement, center 3, 2, and scale factor -1. They're both acceptable answers, although this is the more common one for this kind of question. Okay. Now, if it wasn't 180 degrees, I would then, if it was 90 degrees, for example, I want to pinpoint the center of rotation, I would use tracing paper to do that, which I'll show you when we get a question like that coming up soon, hopefully. Now, triangle X onto triangle W. Now, triangle X onto triangle W, well, this is something that is now being taken out of the syllabus since 2015. It's not been in the syllabus. This is actually something called stretch. Okay, so I'm not going to go through this with you, all right? I'm not going to go through this with you because it's outside of the syllabus now. But basically, if you wanted to describe this, it would be a stretch, and the scale factor would be, for example, you say the distance from the invariant line, okay, which is y-axis here, it's going to be 8, which W is the image, so you're going to put 4 over 8, so that you'll say it's a stretch. Just for those of you who might be curious, a stretch, you say the invariant line, which you don't really need to know, is the y-axis, and the stretch factor is going to be a half, because it's 4 divided by 8. Okay, 4 divided by 8. The distance from the invariant line to the image over the distance from the invariant line to the object. Okay, we could say 2 over 4. Basically, it's going to be a half. Okay, so you don't have to worry about that because it's outside of the syllabus. So don't worry yourselves, okay, about part B. So this is outside of the syllabus, so we can ignore this question for the purposes of your exam. So that question will be outside of your. You don't need to know anything about that. Then it says find the matrix that represents the transformation in B part 3. So again, that's outside of the syllabus, so you don't have to worry about that. Okay, so again, part C is not something that we have to worry about. Okay, so there we can leave it at that, this question. Okay, thank you very much.